Okay, arrow-central movement. Okay, now if I want to talk about arrow-central movement, take a look at the notation here. It doesn't have, when you take a look at the notation here, I put a prime out, okay? But the notation here is actually this. Okay, this is arrow-central movement. Okay, we also call it arrow movement about the mean. Okay, arrow central movement is also called arrow movement about the mean. I need you to pay attention to this guy now. Okay, what is the difference between this guy and this guy? Okay, this actually concentrated around 0, but this guy concentrated around the mean. Okay, now I want to find, and x minus mu is like a distance between a random variable and the mean raised to a power of a constant. Okay, because of the fact that x is a random variable, the whole thing is going to be a random variable. Then expectation means find the average of that. Okay, now do you know when r equal to 1 here? When r equal to 1, okay, for instance, when r equal to 1, okay, I'm actually going to have, when r equal to 1, I'm actually going to have this guy. Okay, I'm going to have that guy, which is going to be expected value of x minus mu, and this guy, which is going to be mu minus mu equal to 0. And that is the reason why we say the first moment about the mean is going to be 0. But the first moment about the origin is actually the mean. First movement about the origin is the mean. First movement about mean is 0. Okay? Now, let's go to second movement right now. Okay, second movement, when r equal to 2, second movement, I'm actually going to have this guy. Oh my God. This guy here, the second movement about the mean is the variance. This is what we call second movement, okay, about the mean. Okay, the second moment about the mean is the variance. Okay, you may be wondering, when we are deriving the variance, we'll be using a particular formula to do that. This is the origin of the formula. Okay, I'm actually going to do something now. Okay, so I'm actually going to do something now. You're going to see, like I said, the second movement about the mean, the second movement about the mean, which is the expectation of this guy. Okay, I also call this the variance of x. Okay, now if I want to expand right now, if I take a look at this now, okay, this is going to be s squared to x mu plus mu squared, right? If you try to expand that, right, then I'm actually going to have expectation of s squared. Expectation is going to attract a random variable x. Okay, mu here, this is a constant, right? So I'm actually going to have 2 mu expected value of x plus mu squared. I've got expectation of a constant is a constant. This guy now, I'm actually going to have this minus 2 mu. This another mu, expectation of x. Okay, expectation of s is actually mu. Okay, now plus mu squared. Okay, so right now I got expected value of s squared minus 2 mu squared plus mu squared, and this is going to be expected value of that minus mu squared. Don't forget, this is equal to that. Finally, I'm actually going to have this minus this, which is the variance of x. Do you remember? We've been using this guy all this while, right? This is the origin. Okay, it's the second movement about the mean. The second movement about the mean is variance. Okay, so it's going to go all the way. Okay, I can also have the third movement. Okay, now when you take a look at this guy now, okay, I want to talk about, okay, now when you take a look at this guy, this is just fourth movement about zero that I've done before. Fourth movement about zero. This guy here, fourth movement about zero. And this guy here now, this is third movement about the mean. Third movement about the mean, which is what I want to do right now. Okay, we need third movement. We need second movement about the mean for variance. We need third movement about the mean, is we need that to be able to get its skewness. That's what I'm going to talk about. Okay, now, okay, so this, right? This is the third movement about the mean. Third movement about the mean. Okay, when you take a look at this guy now, okay, we can actually, uh, you know, this is the same thing as this, right? You can expand, okay? You can even use, has anybody heard about Pascal triangular formula before? Okay, let's see, 1, okay, 1 and 1, right? Or 1, 2, 1, or stuff like that. Okay, so now you can use that, or you can just simply do this, x minus mu. Okay, this guy is what we have here, s squared minus 2x mu plus mu squared. Okay, you can decide to go further. I got s cubed, okay, 2s squared mu plus mu squared x, okay, and minus mu s squared plus 2s mu squared minus mu 3. Okay, now when you take a look at that now, so I got that. Let me see, 2s squared mu. Okay, okay. So when you take a look at this and this, right? Okay. Oh, this is negative. That's like a negative 3s squared mu, right? Okay. If you take a look at this guy and this guy, okay, that's like a 3 mu squared s, then minus that. Okay, you need to understand algebra to do that. Okay, so this is going to be this minus 3 mu expectation of s squared plus 3 mu squared expectation of x minus mu raised to power 3. This is algebra. Okay, just expanding. Okay, now the third movement now. Okay, expectation of that. Okay, minus 3 mu. Okay, when you take a look at that guy, okay, that is expected value of s squared, okay, plus 3 mu squared expected value of s. And here, expected value of s is actually mu. Okay, this guy, mu, okay, minus mu 3. So expected value of this minus 3 mu, expected value of that plus 3 mu 3 minus that. So finally here, you actually going to have this s squared minus 2 mu raised to power 3. If you take a look at what I have here, if I want to rewrite that, okay, I'm actually going to write mu 3. This is mu that minus 3. This is that. This is this minus 2 raised to power 3. Now, what am I trying to say here? Okay, the third moment about the mean can be written as a third moment about the origin. This is first moment about the origin, second moment about the origin, then minus 2 cube of first moment about the origin. So which means the moment about the mean is written in terms of moment about the origin. Go ahead. On the top? Oh, thank you. Plus minus. Thank you for that. Okay, so that is it. So we also we have all the way. Okay, we got all the way. Okay, we also have a fourth movement. We're gonna stop at fourth movement. Okay, fourth movement about the mean. Okay, so fourth movement about the mean. I'm actually gonna have this guy. Okay, all what you just need to do is to expand that. Okay, this is we normally stop right here, and of course, if x is a discrete random variable, of course, this is going to be summation this. Okay, if if s is a discrete random variable. Okay, now